So, hello again, and we're gonna present Kelly's work, and the topic is final presentation. So, he's working with Sapp. It's a drug he's trying to synthesize. It's really expensive to purchase, so here we present Sapp. And here, optimization, and let's hope the video works. Yeah, so some shaking happening. We see what's happening. So it looks cool. Then the idea is we want to put Sapp on Graphene. As far as I understand from quick conversation with Kelly, we're trying to figure out, and Dr. Kale, we're trying to figure out that attachment of this drug to graphene. So is it going to be like hydrophobic interaction? It's going to be with a carboxylic to the graphene. That's a thing maybe computational can show us these results. And here's a movie. I'm not sure what's going to be here, but let's hope did something happen? Yes, so something happened and we see what's happening there, which is vibration. So, for the next slide, so this is density of state of both together. I'm sure Kelly will have, we're going to have to do this, which is doing, computing the density of state of each one separate, then together, which we have here together. The most interesting thing here is he's saying there is zero gap between the valence band and the conducting band. And a simple way to say what's the goal from this, or what do we conclude from this, we just say that it's very conductive. So if we mix those two together, it looks like it's very conductive. But maybe if we just do compute the density of state for this one, maybe it will just be conductive by itself. But that's not the idea if we want to test conductivity or not. It's just a conclusion that some people just observe when they see overlapping between the valence and the conducting band. Here's another one of the same thing. Here's the occupied orbitals, and here's the unoccupied orbitals. But the most interesting, I think, is here. The blues representing with the occupied orbitals, which is on the carboxylic end of the molecule, and the unoccupied orbitals are on the ring. And I assume he did this right and left because this is the unoccupied and this is the occupied. And he picked 220 and 221 just right on the slide and drew the orbitals for it here. And same as we showed with Joe, these are the spectrum. Again, the same idea. The small range, 200, 700, all the range. This because we, scientists, more interested to see the UV vis. And here's the whole range if you're more interested to see like the IR range, more of the electron vibration part. So this is again what he's trying to say. Pretend lines are bonds. Maybe he's trying to say that this might have some hydrophobic interaction, or it would be the carboxylic. And on this one, he was just trying to measure the distances between the carbons here, nitrogen and nitrogen. And that's pretty much Kelly's work, but he ended up with this interesting message. While he's doing calculation, he got this message. And it says here, I hope you know what you're doing. So I hope you know what you're doing, Kelly. And at the end, and oh, he's definitely thanking Dr. Khaled, thanking Wendi again, Adam again, because they work on the carbonate tubes and graphenes, and he's thanking me for the presentation. And the last slide, which I had some comments on, I was almost deleting it, but he said no, you should not delete it. And Shanae Ben and even Mariah made me feel like it's unethical if I delete a slide, so it's gone.
I deleted it.
Oh, good. 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 Perfect. Perfect. It was just a cheesy picture of me with my tongue like that, but who wants to thank me? So, thank you, Kelly.
Okay, let's thank Kelly and Khaled.